Okay, so who are the guys who that are attending from the previous session? We already have a conversation yesterday. I think a lot of people are working on that. Okay, so now let's discuss about the next concept. So, can anybody tell me what was the last topic that we have discussed? Guys, okay. Don't worry. So let us discuss about the next concept. So yesterday we discussed about the what is meant by a container and how containers will be created and how we are going to work with the containers. What is a container and how the processes will be. What are the different features that are available in the Linux environment to create the container. Okay. If anybody is talking, can you please unmute yourself? I'm unable to hear you. Okay, fine.
Sorry, sir. This is my first class, sir, but I can cope up, sir. Thanks.
That's fine. That's fine. So now let's get back to the concept here. So we are going to discuss about Docker architecture. And so yesterday we discussed about what is a container. So let us discuss about how to install the how to install Docker in a Linux environment. And then we will see what is the main concept of Docker architecture, what happens in the backend. So now when we are discussing about this, okay. First of all, let us install or else let me configure an EC2 instance in the AWS environment. Okay. One second, guys. Okay. How to install the Docker on Linux. So first of all, let me deploy the Linux EC2 instance. So launch the EC2 instance, and then what I'm going to do, this is my Docker server. So we are going to learn everything from the AWS and whatever the physical infrastructure that I'm creating, the complete infrastructure will be from the AWS. So Ubuntu, and then I can go with T2 micro is fine. Key pair will be default key pair, and then I'm going to deploy the server. Okay. So this is the server which I want to run, and inside the server, I don't have any sort of Docker installed. So it's an Ubuntu environment. So how we can create the EC2 instance inside that Ubuntu environment? Sorry, how we can create the Docker inside that EC2 environment. So first of all, let me access the server. New session. Okay, hold on. Okay, so this is my Docker. This is my server. Sudo su hyphen, and here, if you can see, how many network adapters will be there. So apt update hyphen y and apt install hyphen y net hyphen tools. So now we created a server. Just try to understand what we have done over here. So this is the server. And if this server has to communicate with the internet, then how servers will communicate, or else if you are having a computer, so if the computers has to communicate with the internet, what should be done? What we need to have for that particular computer, or else what we need to have for that particular server? Come on, guys. Come on, talk. Here my session won't be like any another sessions that I will continuously telling you the concept. I'm continuously feeding into your brain. I don't want to do that.
Sure, sir.
I want to.
Can you repeat the question, sir? Sorry, I found.
If the server has to communicate with the internet, what should be there?
So in SSH group, we have to allow outbound groups,
No, no, no,
outbound
no.
ports.
You are very going very in deep. I
Okay.
am
Internet
asking a
connections.
internet connection where we will connect that to the server. We will connect to the Ethernet port will be there, right? So for the Ethernet port, we will connect. So for every server, there will be an IP address assigned to this Ethernet port, right? For every mission, if you want to connect to the internet, definitely there should be an adapter. Will you accept it? In your laptop, if you want to connect to the internet, there should be a Wi-Fi network adapter. If Wi-Fi network adapter is not there, are you able to communicate with the internet?
No, no, sir.
No, it won't be happen. Okay. So now in the same manner, for your server also, there will be an Ethernet adapter will be there. So we will simply, in the Linux terminology, it is called as ETH0 or else some another name. So it will have an IP address. So it will have a public IP, and as well as it will have the private IP. Private IP. These are the two IPs that we will have. So now, if you can see in our server also, when I go for if config, okay, if you can see here, you can see ENX0 is there, which is having the IP address. So this is the private IP address of my server, 1023.368. This is the private IP address of the server. And if you can see, this is the public IP address of the server. Okay, these are the two IPs that are assigned to my server. Now the point is, here you can see there is another network adapter that is called as LO. LO means loopback adapter. Loopback adapter in the sense, if you are having for testing purpose, you are going to use it. If you are having any problem, so then what is going to happen? Then this loopback adapter will identify, or also it will give an error for us. So there is a problem in your system, or else loopback adapters are especially used for the testing purpose. Okay, so why we are using this? For example, whenever you want to check any application, you will give local host, or else you will give 127 series of IP address. So that is a loopback adapter configuration. Now, if you can see in your server, before installing Docker, we are having two adapters, which is the first adapter is the host adapter, or else the server adapter, which is helpful for you to connect to the internet. And the second adapter is the loopback adapter. For the testing purpose, you will have that. Now I will install the Docker. So you can install apt update, apt install Docker, Docker CE like that. Or else simply with a single command, you can install the Docker. curl-sl https://get.docker.com and bash. So it is going to install the Docker on your server. Okay. So once it is installed, then what you can see here. So here we are installing Docker inside the server. Once the Docker is installed inside the server, then what is going to happen? So this is the Docker engine. Okay. Now Docker got installed. So here you can see Docker info, which is going to show you the Docker version and everything, and as well as Docker PS. And if I go for if config, now how many adapters are there? Previously, how many adapters are there?
Now
Previously,
three.
how many adapters?
Previously two, now three, sir.
Now we are having a new adapter that got added for your Docker server. So this is my custom adapter which has been added when install the Docker. So this is called as a default network adapter. So this is called as a default network adapter which is added to your Docker server. So now if any container is created, if you don't specify the network, automatically that container, whatever the container is there, that particular container will be added to this default network adapter. Whatever the container that we created, if I don't specify the network name, automatically it will be connected to your default network adapter. So this is my Docker 0 adapter. Now here, let me show you one thing. So Docker network ls. Here you can see we are having 3 network adapters. One is the bridge network, which has been created just now. After installing your Docker, a bridge network will be created. What is a bridge? What is the functionality of the bridge?
To give connection to two different things, like not two different
To
states.
connect to two different things, right? So
Yes, sir.
now what can be done here means, okay, now what can you understand here is it can connect to the Docker containers to your external network adapter. So whenever you want your Docker containers to communicate with the internet, then the default Docker or else default bridge network adapter will act like a bridge, okay, to make the connection between container and to your internet. So this is fine. So now what I can do, so if I create a container, docker run -itd, what is the meaning of this entire command? So docker means you are communicating with the docker CLI and the docker daemon. So whenever at any given point of time, here you can see docker network, docker run, and if you can see here, I can give a command called as docker ps or else docker images, docker volume ls. Okay, so everything, okay, whenever we are executing any command in the front, we are giving the docker as the instruction, which means that, so docker is the CLI. So we are communicating with the docker CLI. From the docker CLI, the commands will be executed by the docker daemon. So whenever we want to create anything or else whenever we want to check anything, the user will directly interact with the docker CLI. So now here I want to create a container, docker run -it. IT means interactive terminal. So whenever a container is created, a terminal should be there. So where I can communicate with the terminal. If I want to pass certain commands, so I can pass the commands through the terminal. And D means in the detached mode. What is meant by detached mode? So whenever we create the container should run in the background. So the container should not be running in the foreground. So if I want the container should be running in the background, so I can give a switch called as D. D means detached, which will be running on the background of your Linux environment. If I don't give D, then what is going to happen? --name test container, and with the image Ubuntu. Simply I will give like image Ubuntu. So now if you can see in the Docker images, in the Docker image, we don't have the image. No. So then what it is going to say, unable to find Ubuntu latest locally, it is creating the it is creating the container. Here you can see how you can say that it created the container. So what is the command that you are having? Here you can see root@IP 10.20.368. So basically I am in the server. But if you can see the command right now, if you can see the prompt right now, so what is the prompt showing you here? root@. So this is the ID. So what is this ID? This ID represents your container ID. So we are currently inside the container. So the container got created and we are directly into the container. So which means that the container is running in the foreground. So it's not like a normal process. So if I have to show you something like this, so what I can show you is if any application I want to run, so maximum number of processes that you are seeing here, all the processes will be running in the background only. So now if I give -it, then what is going to happen? The container will be created and here you can see the container will be in the foreground. Okay. So foreground means we will be directly logging into the container. If you want to execute any command, you are executing inside the container. So don't think that we are executing inside the server. So whenever I don't give D option, then the container will be running in the foreground. If I give the D option, what is going to happen? -itd container2. Now you can see I am not directly logged into the container. Still I am on the server. So which means that the containers are running in the background. So the test container 2 is running in the background, whichever we have created right now. So that is the main difference between when you give D and if you don't give D, what is the main difference? Okay, so here the container got created. This is fine. So the next one is when we want to create a container, we are getting some messages. What are those messages? First of all, let us see the architecture, Docker container architecture. Okay. So when I come here, so every time the user will be communicating with the Docker CLI. Every time the user will be communicating with the Docker CLI. So whatever the commands that we are passing, Docker run, Docker start, Docker build, like that. Whatever the commands that we are running on the Docker CLI. When we run the commands will be passed to the Docker daemon. Here you will have the Docker daemon. So this is the Docker daemon. So the Docker daemon will execute all the commands. The Docker daemon will execute all the commands. Now, if I want to create a container, we will have actually, there will be registries. Okay, one is the global registry, and the other one is the private registry, private image registry. I can call it as global image registry and private image registry. And then we will have local image registry. So what is this global image registry? It is nothing but your Docker hub. Docker hub, where you will have all the images inside the Docker images. In the Docker hub, we can find the basic to advanced images. So these images will be available inside the Docker hub. Private image registry means it is the image storage for your organization. So if you are having an organization, inside that you want to create certain containers. So for creating the containers, definitely we want the images. So we will generate our custom images. For example, there is a bank application is there. For bank application, I want to create an image. So that image I cannot expose to everyone. So that will be belonging to within my organization. So whatever the images that are available within my organization, all these images can be stored in the private image registry. The best example is Nexus is one kind of private image registry, and Harbor is also one of the type of private image registry. And the next one is local image registry. It is the image storage inside the local server, whatever the local server that we are having, or else inside the Docker server, we are going to store where the images are getting stored, or else where the images are available. So then that is called as a local image registry. So right now inside the server, you will have a local image registry where you will find lots of images. How we can find the images? When I give the command Docker images, here you can see I am having a Ubuntu repository. Inside that we are having an image that represents the latest. So we are having an image. So inside my local registry, so this is my local registry of my server, local registry. Inside that I am having one particular image. One image is there. That is Ubuntu. You think this is the image? Okay, this is fine. So let me do one thing. I will keep a box over here. What is this box? I will tell you. Okay. So we are having Ubuntu image. That is what you are thinking. Okay. So this is the image which is available. With the help of this image, what I have done here is I created a container, or else I created minimum 3 containers. One is test container 1, and test container 2. Like that, I have created 3 containers with the help of this image. I created a container. Okay, this is good. So if I want to create any another container, so docker run hyphen itd hyphen name test container 100 ubuntu 22.04. So now when I try to create the container, now you tell me one thing, whether the image is available with me. Do I have the image available with me inside my local registry? Do I have the image?
No.
Everyone. So do I have the
No,
image?
sir. No, no.
No. So we
We
don't
don't
have
have.
the image. Okay. But here we have the Ubuntu, no? So how can you say that the image is not there?
The tag name is different, I think, here.
Okay. One second. So here you are saying that
Ubuntu tag name is different. No,
Ubuntu tag name is different. Okay, very good. So now what is this Ubuntu called as? So now when I say the image is a combination of repository name and the version name, or else repository name and tag name. Image or else Docker image is equal to Docker image means what I can say repo name plus tag name, or else I can call it as version ID also, tag ID or version ID. Version ID. So this is called as your Docker image. So now here we want to pull the Ubuntu. So already I have the Ubuntu repository. Here you can see already there is a Ubuntu repository, but the tag is different. So now if you can see what it is saying, unable to find the image locally. So whatever the image that you are specifying 22.04 is not available. So I am downloading it. So from where it is downloading, I will tell you later. So now if you can see Docker images, here the repository is same, Ubuntu repository, but when you see here, the tags are different. This will make a separate image. For example, let me give you an example. You have the Windows operating system. Windows 7 is there, Windows 8 is there, Windows 11 is there. Now when you see in the operating system wise, everything comes under the Windows itself. But when you come to the version wise, automatically there is an upgraded versions are available. So which means that even though the software platform is Windows, but still you have a different kinds of operating system. In the same manner here also, even though the repository name is same, but the versions are different. So that's why it is saying that I am unable to find the Ubuntu 22.04 locally. So I am pulling it from where it is pulling. So if the image is not available locally, then Docker will directly go to the hub.docker.com. So into my Docker hub, which is a global repository or global registry. Inside this global registry, we will have multiple images. We'll have the so many images. Either it might be Ubuntu repository kind of images, or else Nginx kind of images, or else Tomcat kind of images, Java kind of images, Maven kind of images, or else Red Hat, Ubuntu. Like that, you will be having so many different types of images that are available inside my Docker hub. So this is my Docker hub. So from the Docker hub, what it is going to do, it will pull another image from the Ubuntu repository, and it is going to place it in my local system. From the local system, it is going to create another container. So another container will be created over here. So this is what going to happen with the architecture. So whenever any containers or whenever the containers has to be created from the Docker, first the user will provide the Docker run command with the help of Docker CLI. From then it will goes to the Docker daemon, and the Docker daemon will search for the image inside the local registry. If the image is available in the local registry, it will create the container. If the image is not available in the local registry, then it is going to pull the image from the Docker hub. Okay, it is going to send a request to the Docker hub, and from the Docker hub, it is going to pull the image. From this image, it is going to create another container. Or else, if you want to build your own image, so we can build our own image with the help of Docker file. So that's where this Docker build command will come. Whenever we go for Docker build, so then what is going to happen? It will build the image and stores in the local registry. So when the image is available in the local registry, and if you want to make it global, you can push the particular image into the Docker hub. This is what your entire Docker architecture is all about. Now, if you see here, Docker architecture, look at there. They will see here the client, nothing but Docker CLI. When we give the commands, that will communicate with the Docker daemon, and it is going to run the containers with the images that are available. If the images are not available, it is going to pull the images from the Docker registry. From the Docker registry, we can, whatever the images are pulled from that, we are going to create the containers. So this is the concept of your Docker architecture. Do you understand now? Any questions?
Yeah, I had a question. Could you explain the Docker start
Sorry?
or the pull? The Docker start, the start Docker pull?
Docker pull.
Yes.
Docker pull means you want to, if you want any image to be pulled from the Docker hub, you can go for the Docker pull command. Docker pull nginx. See that? It is going to pull the nginx from the Docker hub. What it is going to pull? Docker images. The nginx image will be pulled from the Docker hub. That is what Docker pull is all about. Okay.
Okay, so it pulls it from global to local. I got you.
Yeah, global to local. That's it. That's about the Docker pull command.
So Chaitanya, you mentioned that private images is ACR is not comes under private image repository, or how it is?
Sorry.
ACR not comes under private image
You are
repository.
talking about AWS ECR.
Yes.
It will
ECR
come
or
under
ACR,
the
anything.
yeah. Azure Container Registry, or else that's why ECR means Elastic Container Registry. It is also going to come under the same private registries.
Okay.
Okay. Right. So this is about your Docker architecture. The next one is, okay, the containers are created and we are able to run the containers. This is fine. So now what is the Docker life cycle? Docker lifecycle in the sense container lifecycle, how this container is going to be created and what is the container lifecycle. So to know about that, so whenever we are creating the container, what is the command that we are providing? Docker run is the command that we are providing. Docker run means automatically into which state the container will be. Docker PS in the sense the status is up and running. Up and running means up means it is running. The container is in the running state. So basically, what are the different states for the container here is, you will have, first one will be create. This is the first state. And then you will have start. And then you will have run, pause, unpause, stop, start again, and remove. These are the different states for your Docker lifecycle, or else container lifecycle. I will call it as a container lifecycle. So whenever you want to create a container, you can create the container. So that will be in the created state. Container will be created and it is not running. Created. So once the container is created, once the container is created, then we are going to run the container. Then we are going to start the container. Now container will be run in the running position. So I can start this. This is the second one. So when I start this, automatically it will be the running position. But what we are doing, we are bypassing these two life cycles. I mean, bypassing these two phases, and directly we are into the run position. We are into run. So this is called as run position. From run, what I can do when the container is running. So if there is a high CPU utilization is there. Okay, suddenly the application is consuming lot of CPU. Okay, so the other containers are not able to run because of the one container. The rest of the containers are not able to run. So now what I want to do, I don't want to delete the container. I don't want to delete the container, even though inside the container we are having the application. I want the application should be running, but the container should be in the pause state. So how I can do that? So what is meant by pausing? What is meant by pausing? Okay, let me take an example. Do you play any video games? Video games, or else I can say you in your mobile, like any some XYZ games will be there. When you pause the application, when you pause the game, whether the game will be restarted from the beginning or else it is going to start from where we have paused, from there it is going to start. Do you understand my question here? If I pause the game, whether the game will start from the beginning or else it will be resumed from where we have stopped.
Resume, sir, resume.
Resume. So which means that, so inside your computer or else inside your mobile phone, you are having the application. So now how my computer know that this particular application is paused at this particular point of time? See, I'm asking you a general question. The question is very simple, guys. When you are running an application, suddenly I want to pause the application. You will pause the application. When you pause the application in your mobile, or else you are watching a video. Whenever you are watching a video in YouTube, you want to pause the video. So when you pause the video, how your mobile phone or else how your laptop will know that this is the exact time frame where this particular video has been paused? Tell me.
I think it might capture the state of container.
I'm not talking about the container here. I'm talking about the generalized configuration. Okay.
Thus it's a time frame. I think it will record a time frame in between.
It's not about the time frame. So whenever you are running an application, whenever you are watching a video, actually that video should be processed by the processor. Then only you can hear the voice, then only you can see the visuals. Now, if the voice and visuals has to be processed, this processing will be happen if that data is stored inside the RAM. If the data is stored inside the RAM will forward the data to the processor to process the application. When I pause the application, CPU will not accept it, or else CPU will not process that particular data. CPU will not process the data, but still you will have the data available inside the RAM. So if there is an application running, when you pause your gaming application, let us come back to your gaming application. When you pause the application will be present inside the RAM. Okay, at whatever the state it is, it will be present inside the RAM. And then what is going to happen? You are pausing it. You are stopping the process. I don't want to process that application. Now the processor won't process that. When you pause it, it won't process that. But the application is not killed. It is not stopped. It is not terminated from the RAM. It is not going to be wiped out from the RAM. Still the application will be present inside the RAM. So the RAM consumption will be there. The memory consumption will be there. But the processing won't be happen. So that is called as pause state. And then when you unpause it, or else when you resume the application, and again, the RAM will forward the data towards your processor, and the processor will process the application. So this is called as pausing and unpausing. Now in the same manner, here also, whenever the container is running, if one container is consuming a lot of CPU, and I don't want, because of that container, I don't want the other containers to be affected, what I want to do here is I can pause that particular container. For a while, I want to pause that container. So for that, what I can use a life cycle called as pausing, and once and later I can go for unpause. Okay, so this is when I unpause it, automatically it will come back to the run state. And the next one is stop and start. When I am running the container, suddenly I don't want this application to be running. So simply what I can do, I can stop the container. So stopping means completely terminating the application, just like shutting down of your system. So pausing is like hibernate mode or else sleep mode. Stop means just shutting down your computer. So when we shut down the computer, the application won't be available anywhere. Whatever the open application are there, all the application will be closed. But when we keep the computer in the hibernate mode or sleep mode, in the background, you will have the application, but the processing will not happen. So here also pausing and unpausing means it's like it is just like a sleep mode or hibernate mode. But when you come to the stop means shutdown mode. The entire application will be wiped out. We need to start it from the beginning. This is called stop. And then we will have start. Stop and start. When we start it again, the application, the container will come back to the run state. So at the time of stopping, if you want to delete the container, you can delete the container. So whenever the container is in stopped state, then only you can delete the container without any forceful deletion. Okay. So if the container is in stop state, then we can remove the container. Okay. Remove. Or else when the container is created, then also we can remove the container. When the container is created, then also we can remove the container. If the container is not started, it is not in the running state. Both the ways, either it is created and not started, or else it is stopped and not running. So then also you can remove the containers. So this is the process. So now if I want to remove if I want to remove the running container, we can do that. But this is in the forceful manner, not in a quietly simple manner. We have to forcefully remove that. So what I have to do, I can go for remove -f, rm-f in the sense remove forcefully. So this is how I can remove the container forcefully. Okay, good. So now let me go back here. I want to create a container. Docker create -it -it or else -itd name nginx container with the nginx image. Nginx image. So Docker create nginx -itd, or else let me go with the -it option. So here you can see the container got created. So if you can see docker ps-a, if you give the command, what are the containers that are running? So for to check the running containers and stopped containers, you can give a command called as docker ps-a. So now you can see here the nginx container is created, but it is not running. So whenever the container is running, here you can see up symbol will be there, or else upward will be there. Upward in the sense it is going to tell you the container is running. So when I go for docker start nginx, now the container will be started. Docker ps. Here you can see from the last 2 seconds, the container is up and running. Okay, so this is called as create and start. Create and start, then the container will be into the running state. So we are bypassing these two life cycles, by bypassing these two stages, directly we are going into the run stage. So now if we can see Docker, what I can do here, Docker, just forgot this, Docker -help, Docker rm, not the restart. I want to check the CPU and memory utilization. There is an option I just forgot. Just give me a second, guys. Yeah. So Docker stats. When I give this, automatically here you can see each and every container stat you can see here. From my entire 1 GB of my system space, whatever the system RAM I am having. So from the 1 GB, so one container, test container is consuming 0% of CPU and it is using 964 KB of RAM. Here you can see test container 1 is consuming 4 MB. Test container 2 is consuming like this, and nginx container is consuming 10 GB. For example, Docker stop, I want to stop all the containers at a time. So here you can see Docker PS means it is going to show all the containers. Here you can see the container IDs are there. So if I want to only the container IDs, what I can do, Docker PS-AQ. If I give this, here you can see these are the container IDs. Okay, whatever the container IDs, here you can see that. Now I want to stop all the containers. What I can do, docker stop $, docker ps-aq. So all the containers will be stopped. This is the stop state. So in the after stopping, then what we can do, we can terminate the containers. So here you can see docker ps. We don't have any running container. So when I go for docker ps-a, all the containers are exited. Exited means shut down. So now what I can do, docker rm $, docker ps-aq. When I give this command, then all the containers will be removed. Docker ps-a, we don't have any container there. In my Docker server, I don't have any container. So now what I can do, docker run, or else docker run -itd -name nginx container with the nginx image. So a container is created, docker ps and docker stats. I want to know what is the CPU and memory utilization of that particular container. So it is using 2 MB of memory. So let me log on to another session of the same server. I am logging into the another session of the same server. Sudo su -, and then I am going to virtually put load on that particular container. Docker execute. So this is the command to log in into your container. So docker execute -it nginx container and bash. So now you will be inside the container. So look at that. So previously we are in the server. Now we are in the container. Now what I can do, apt update -y and apt install -y stress. I am going to install stress. Look at that. Okay, when I go for stress, I will apply the stress for 10 minutes. I am going to apply the virtual load for 10 minutes. When I apply the virtual load for 10 minutes, see the CPU utilization of that particular container. The CPU utilization has gone beyond 90%. So which means this container is totally capturing my resources. I don't want this to be happen. So on the RAM utilization is somewhere like 200, in between 100 to 200, it is fluctuating. Now what I can do here to explain you about the Docker pause, let me take a duplicate session. Sudo su -, docker pause nginx container. When I give this, now here you can see the CPU utilization has become 0, but the memory utilization is still on the same 147. So why? Because the particular application is still present inside the memory, but it is not getting processed. So here what is going to happen when I unpause it, which means that the stress application is not terminated. The stress application is not terminated, but it is paused state. Now what I can do, I can go for docker unpause nginx container. When I do that, docker unpause nginx container. So when I do that, automatically again the stress application is running. So it is going back to the high CPU utilization. So this is how you can go for the pausing and unpausing of your containers. So actually, when you are going to use this kind of life cycle, this kind of stages means whenever if the CPU utilization is very high, at that particular point of time, what we can do, we can go ahead for a concept of okay, so when we are going ahead with the concept of Docker, when there is a huge amount of CPU is consuming, then we can go for pausing and unpausing. Now, when I go for Docker stop nginx container, then the container will be completely terminated. The application will be terminated and the container will be completely terminated. Now, when I start it again, Docker start nginx container. Now the container is started. So here you can see it will be exited. See there. So now actually we are present inside the container, but when I stop it, automatically I came out of the container and I am right now inside the server. So which means that when we go for Docker stopping, the application will be completely terminated. So that is the another life cycle for you. So these are the total life cycles that you can understand. One is create, start, run, pausing and unpausing, stop and start, and then remove. These are the concepts. Okay, I hope you understand this. Any questions?
Yeah, I had a question. So you were saying that when there's high CPU usage, in order to decrease the CPU usage, you could use pause, right? And that would stop the process from running, but still consume memory within the application, right? Is that accurate? And then
It is going to consume the memory. Consume the memory in the sense the application will be in the pause state. When it is in the pause state, how much amount of memory it is consuming, it will be in the static one. For example, whenever the application went into the pause state, if the application is consuming somewhere like some 1 GB, it will be paused over there. It will be freezed. The application will be freezed. It is not going to over consume the extra amount of memory there. Whenever it is processing, then only the extra amount of memory will be consumed. But when it is freezed, then extra amount of memory is not going to be consumed. So that is called as pausing. That is what your question is, right?
yeah, and then when you have the CPU, when you have high CPU usage, right? If you want to reduce that, which command are you using for that?
You need to check the logs. Until
Okay.
unless if you don't check the logs, how can I know that the CPU, why the CPU is hitting at its high peak levels? I cannot say no.
Right.
So
I do. I understand you have to check the logs, but I'm saying you were able to see the amount of CPU usage here.
this is, I'm just getting out from the container stats. From the container stats, I am able to see that this particular container is consuming high amount of CPU. And I don't know why it is consuming the high amount of CPU, no?
Okay.
So in the back end,
Okay.
inside the container, a stress application is running. I know that. Why? Because I have started it. So I know that. But in general, when you go for the real-time example, in real-time scenario, we might not know. Some of the Java services may consume a lot of CPU. So that might be a reason. Because of the memory garbage issue, the application may consume a lot of CPU. So that I cannot say no. So we need to check the logs.
Okay, I understand now. Thank you.
Yeah. Anything else, guys?
So yes, so you are sharing, I think, this notepad with any content of any means like a definition of Docker, different Docker topics, or how?
I will share you the Word document with you, not the Notepad document. I have a separate Word document for this Docker, so I will share you the Word document once we are into the Docker concepts.
Okay. So in that document containing all the commands also, what we are using daily to daily basis, right?
Yeah, you will have all the commands.
Okay. Thank you.
Okay, guys. So that's it from my end. And today is the last demo session. I'm sorry, those who has joined this session. So today is the last demo session, and from tomorrow onwards, you have to join into a premium session. Like whoever has pay the fees, they will be joining into a premium. They will be given with a separate Zoom link, so that you will be able to join into that particular classes. Okay.
So, sir, one general doubt, sir. So total class will be completed in 20 days, sir.
25 days.
Okay, sir. Thanks, sir.
In the advertisement, we can say that within 20 days, but whatever the syllabus that we have discussed, so it is very tough to complete the concepts within 20 days. It definitely will take 25 working days.
Sure, sir.
Okay.
Thanks, sir. Okay, sir.
Yeah, fine.
Is
Okay,
that
guys.
are we go? Also, one more thing. Is that
Tell
are
me,
we
tell
going to get recording videos?
Yeah, every day you are going to get the recording videos, you are going to get the material, and you are going to get the whatever we have done, the practical related documents you are going to get. So you will get everything. Don't worry.
Okay, via mail or like we need to join any particular group.
So you can get it from the whatever the Gmail account that you shared with the DurgaSoft. They are going to share you with the Google Drive. Share you all the videos in the Google Drive so that you can access them. Okay.
Yeah. Thank you.
Right. Okay, guys.
I have
Yes.
one more question. And
Yeah.
you said you are going to cover Terraform in this session, right? During this
Sorry.
session. Are you going to cover Terraform in this session?
No, Terraform is not going to be covered in this session.
Okay.
Okay. Okay, guys. So I hope that I made every doubt clear. Anything else from your side, you can just let me know. Fine then. Have a nice day and we'll meet in the next session. Bye, guys.